So now we are going to look at the problem that is rotate matrix. So rotate matrix by 90 degrees, or we can also say as rotate image. We also say this as rotate image. Okay, we have given a matrix and we need to rotate it by 90 degrees in a clockwise direction. This is clockwise direction. We should need to rotate it by clockwise direction, right? Then it will be look like this, right? Okay. For this, let's try to go with the brute force solution. As a brute force solution, and as a brute force solution, I'll create an answer array, answer matrix. Create answer matrix, and I say this first row is going to be my last column. This first row is going to be my last column. Then I write this. Then does it look like? It look like 1, 2, 3, 4. Then this second row is going to be my second column, second last column, right? Then the second row is going to be my second last column. Then it is look like this. Then my third row is going to be my third last column. That would be mm, this, right? Okay. And then this last column, this last row is going to be my last column, fourth last column, right? Then it will be look like 13, 14, 15, and 16. So here what is happening is my first row is going to be my last column, right? So this is the answer array. This is the answer matrix. This is my answer matrix, and it is a the matrix is given in a size of n into n size, n into n size matrix was given to us. And we should need to solve this in the brute force solution. It's look like this. And what did I do here is what I'm going to do here is I will erase this thing. Okay, and I say so I'll try to write the index first. So this is 0, this is 1, this is 2, this is 3, and we have given the size is n equals to 4, and this is 0, this is 1, this is 2, and this is 3. So let me write the index here also. This is 0, 1, and 2, 3. 0, 1, 2, 3. Okay, that's good. I say let's try to write this thing. So I say 1. So 1 is at the index of 0 and 0, right? Here the 1 is at the index of 0, comma 0. And here the 1 is at the index of 0, comma 3. So this index is equals to this index 0, comma 0 index is at the 0, comma 3 index. The 1 here in this matrix is at 0, comma 3 index in this matrix, right? In this matrix. Then I'll say for 2. For 2, it is at 0, comma 1, and here the 2 is at 1, comma 3. Here 2 is at 1, comma 3, and let's go for 3. Let's go for 3. Then 3 is at 0, comma 2 index, and there it is at 2, comma there it is at 2, comma 3 index. And I say so 4 is at 0, comma 3 index, and here the 4 is at 3, comma 3 index. So 3, comma 3 index. 3, comma 3 index, right? So this is my first this is my first row, right? This is my first row. This is first column, right? This is my first row. I've completed my first row. Then I'll go for the second one. That is 5. So 5 is at 1, comma 1 index, and here the 5 is at 0, comma 2 index. 0, comma 2 index, and it is at 1, comma, and 6 was at 1. Sorry, this was at 1, comma 0 index, right? 5 is at 1, comma 0 index, and 6 was at 1, comma 1 index. 1, comma 1 index, and it is at see here the 6 is at 1, comma 2 index. Yeah, and here this 7 is at 1, comma 2 index, right? Yeah, here the 7 is at 2, comma 2 index. 2, comma 2 index, and here the 8 was at 1, comma 3 index, and here the 8 was at 2, 3, comma 2 index. Here I say 0 is at here I say for the 0th row it is going to take third column, right? For the 0th row. So this, as you all know, this is the 0th row, this is the 0th row, and it's going to take the third column. It's going to take the third column, right? For that I mentioned, so for the 0th row, it's going to take the third column. Then how could I write this? 0 will be my I, and third column will be my n minus 1, because n minus 1 means last index. Last index is 4, right? That means 0, 1, 2, 3. 0 indexing. Then I can say with this, with the help of this thing, I can say 1. So the 1 is at, so the first row was at second last index. How could I write this thing? So I say this is I, This is n minus 1 minus I. So okay, let's try to do this. I say 1 is I, then we know n is equals to 4, then 4 minus 1 minus 1, I say, then it will be like 4 minus 2, and we have got this. This is how we got. I say, so this is my I and this is my J, right? And for every I and J, this is my J, and here 0, 1, 2, 3, and where is here also this J is for this J, this J is for this J, and this J is for, yes, this J. And what about this 3, 3, 3, 0, 0, 0, 0? What about this 0, 0, 0, and 3, 3, 3, 1, 1, 1, and 2, 2, 2? What about this? So for this, we have written the formula here, that is this, right? N minus 1 minus I. So it's going to be for this. I say this is, I'll write this here, n minus 1 minus I. So this is for this. So let's try to code this thing. I say code. Okay, I'll create an answer array to store my answer matrix. I create an answer array and I'll iterate to the loop. Then it will be like, yes, then I'll iterate to the loop 0 to n, and this is also 0 to n. Then what I say is, um, if the array of j is, and the an array of j and n minus 1 minus I is equals to, so this is my, not array, this is answer, right? We're going to put the answer, right? So this answer is equals to my matrix of I and j. So this is my code. This is how it used to look. Let's write in less time complexity, because here the time complexity is like n into n, and we know n into n is n square, right? SAP go of n square, and the space complexity will be like big O of n square. Why the space complexity is like big O of n square? Because we are storing a 2D matrix, that is answer matrix. We're storing a 2D matrix, that is answer matrix. For that, space complexity is big O of n square, and the time complexity is also big O of n square. So this is the brute force solution for rotate matrix 190 degrees, or rotate image also you can call it. So let us try to look the optimal solution for the rotate matrix. So let's try to look the optimal solution. So I say optimal solution. So how does the optimal solution is used to look like? So in the optimal solution, what we're going to do is we're going to do the optimal solution in place. In place, we're going to do the optimal solution in place. In place, what is in place? We're going to do the optimal solution within the matrix. We're going to do within the matrix. We're going to do within the matrix. We have to do within the matrix. Let's try to erase this. Okay. Here I can say that what I should need to do is I'll do a transpose. What I do, I'll do a transpose. I'll do a transpose. We're not changing, we're just modifying the array. We are not creating any other array, not like that. We're just transposing the array, transpose the array. What will happen after the transpose? How does it even look? If I'll take this one, in transpose, row will become column and column will become row. Okay, this is transpose. So I'll take first row, that is 1, 2, 3, 4 as my column. Okay. So I take it as a column, then I say 1, 2, 3, 4. Then I'll take second one, that is 5, 6, 7, 8. Then I say next one 9, 10, 11, 12. Then I say next one 13, 14, 15, 16. So this is my transpose. This is my transpose. So here what we have did here is, here we have taken the first column and make it as a first. Here we have taken the first row and we have transposed here to first column. Right? We have taken the first and make it as first column. Right? Here the row is converted into column, and the column is converted into row. So this is transpose. This is transpose. And what should we need to do? This is our answer, right? It's how does it look? 13, 19, 5, and 1. But we have got 1, 5, 9, 13. So what should we need to do? What should we need to do? We should reverse it. What should we need to do? We should reverse everyone. We should need to reverse everyone. What we need to do? We should need to reverse everyone. So let's try to know how the transpose used to work. Let's try to know how the transpose would used to work. I say, if I draw the diagonal here, 1, 6, 11, 11 and 16. We've got the diagonal for here, 1, 6, 11, 16. And as for the same, we have also got the same here in the transpose, 1, 6, 11, 16 after the transpose. And what should we need to change is, we should need to change these elements. We should need to change these elements. How could I just do in the transpose? I'll start from this. So, okay, let me erase this. I say, this 2 is here, and here we have got the 5. We've got the 5, right? I say 2 is at 0 comma 1 index, 0 comma 1 index, and then my 5 is at 1 comma 1 index, and my 5 is at 1 comma 0 index, right? So what we do here is we're just going to swap both this. We're going to swap this 2 and 5. We swap this 5 and 2, then it will become 2, then it will become 5, then it will be a transpose, right? So that's how we're going to do. That's why I write the index 0 comma 1 and 1 comma 0. Then I say it was done. Then I'll go to the next. Then I go to the next, that is 3. That is 3, right? 3 is 0 comma 2 index. 3 was at 0 comma 2 index, and later that 9 was at 2 comma 0 index. 2 comma 0 index. Then I go to 4. Then I go to 4. I've got this 4 at 0 comma 3 index. 0 comma 3 index. And I've got this 4 at 0 comma 3 index. And here we've got the 10, right? We have so need to check for 13, right? 13. I say 0 comma 3 index is at 13 was at 3 comma 0 index. And for the next one, for the next is 7, right? The next is 7, that was at 1 comma 2, and my 10 was at 2 comma 1 index. Yes. Then I say 8. Where is 8? 8 was here, right? 8 was here, that is 8 was at 1 comma 3, and it was at 1 comma 3, and then we've got this 3 comma 1. 15 was at 3 comma 1. Then I'll say 12. 12 was at where? The 12 was at here. 12 was at here at 2 comma 3. 12 was at 2 comma 3. 12 was at 2 comma 3, and then 15 was at 3 comma 2. So this is how we write. So this is how we write here. And what I'll say here is, so to achieve 5 here and 2 here, to achieve 5 here, 2 here, 9 here, 3 here. So what we need to do is we should swap them. We should swap the index. We should swap this with this. We should swap this with this, with this, with this, and with this, with this. We should swap all of this. Then we get it like 2, 5, 3, 9, 7, 13, 10, 8, 12, 15, 14, in that way, right? To achieve this, we should need to swap these things. To achieve this, we should have to swap this. So I say for the 0th row, you have traveled from 1 to 3 index. For the 0th row, this is the 0th row, you have traveled from 0 to 3rd index, right? You have traveled from 0 to 3rd index, right? For the first row, you have traveled from 2 to 3 index. For the first row, you have traveled from 2 to 3 index, right? 2 to 3 index. Let's try to write this. For the 0th index, you have traveled from 1 to 3 index. You've traveled from the 1 to 3 index. Then I say remove this for some space. Yeah. And for first index, you have traveled from 2 to 3 index. 2 to 3 index. Then I say this is I, and this is I plus 1, and this is, as you know, this is our last index, right? And we know this as well. This is I, that was I, and this was I plus 1, as it is same, and that was, and 3 is our last index. We only with, so 3 is our last index. So what I say here is we'll go I equal to 2 n minus 2, not we got n minus 2 second last index. So we should start from 0, and we went to 2. We have started from 0 and we went to 2 because that is where our the last index was, right? We've started from 2. Here you can observe this is 0, this is 0. Yeah. So we have started 0, and we have go up to 3, right? Here we have started from 0 and we have go up to 1 to 3, 1 to 3, right? And for the first row, we have go, for the first row we have go to 2 to 3, we have go to 2 to 3. For the first row, we have go to 2 to 3, and for the third one, we have go from 2 to, we went from 2 because there is only our last element was, because here the last element is 12. We went for this for the last element, right? So okay, so let's try to code this thing quickly. Let's try to check how the code will look like for this. I see I'll take a loop for I equals 0, and we start from n minus 2 index. Then I'll say write another loop, j is equal to I plus 1, j is equals to I plus 1, and we'll go like n minus 1 index. Then I say once you find it, you should swap that with the, you should have to swap that a of ij, and you should swap that to a of j of I. And once you have swapped it, we should need to reverse it. Here we have note 2 points. First one, we should need to transpose. We should need to transpose, and second thing, we should need to reverse. We should need to reverse, right? Then we get this. Once we reverse this, once you reverse this 13,951, then we'll get here 13,951. It'll be like 13,951. Once you have reversed it, then you'll get it. For that, we should write the code. Then it's a simple one. I'll say for I is equals to, I'll go up to n. Then we just reverse, and this is how it used to work. Let's try to check. This is for the last element, and let's try to check the time complexity. Time complexity is we go of n into n plus we go of n into n. Why n into n? This takes n into big O of n into n, and this loop take big O of n, and this is also take big O of n, right? Then it will become big O of n into n. This is how the time complexity works. And see, this is the time complexity. Let's try to analyze the space complexity. Space complexity is big O of 1 because we are not using, no extra space is used. No extra space used. So this is the time. This is the optimal solution for rotating the image and rotating the matrix at 90 degrees.